Okay, we're going to look at some quadratic inequalities. So a quadratic inequality is when you've got a quadratic expression, for example, x squared plus 3x minus 4, but instead of it being an equation, it's an inequation or an inequality. X squared plus 3x minus 4 is greater than 0, so that's a quadratic inequality, therefore it's a quadratic inequality. So we're going to look at how to solve these. So x squared plus 3x minus 4 is greater than 0. First thing to remember about quadratic inequalities is you must sketch the quadratic function in order to solve the quadratic inequality. So the first thing that we can say here is that it's a positive x squared, therefore it's going to be concave down. Now the next thing that we're going to look for is the roots of the quadratic, the roots of the parabola. So x squared plus 3x minus 4, let's make it equal to 0 to find the roots. Two numbers that multiply give minus 4, add together to give 3, is x plus 4 bracket x minus 1 is equal to 0. That's x plus 4 could be equal to 0, or x minus 1 could be equal to 0, which means I've got a root at minus 4 and a root at 1. It's concave down, as we've already established. I've got a root at minus 4 and a root at 1. And there's a sketch of the parabola. Now, we're interested in when this quadratic, where this parabola is greater than 0. So it's greater than 0 above the x-axis. So we can see there that it's below the x-axis, and here it's on the x-axis, but here it's above the x-axis, and here it's above the x-axis. So the solution then is x is, well, it's before it gets to minus 4, so x is less than minus 4, and after 1, x is greater than 1. Okay, let's try another. So this time we've got x squared minus x is greater than 6. So let's first of all bring that across. That'll be x squared minus x minus 6 is greater than 0. So it's a positive x squared, that's concave down. We're now going to look for the roots by making the function equal to 0. Two numbers that multiply give minus 6, add together to give minus 1. That will be minus 3 and plus 2. So x minus 3 is equal to 0, or x plus 2 is equal to 0. And that will give me a root at 3 and a root at minus 2. So there's a sketch. It's concave down. We're looking for where the function is greater than 0, so again that's above the x-axis, and that's here and here, so that's x is less than minus 2 and x is greater than 3. Okay, let's try another. We're going to solve x squared plus 3x is less than 10. So let's first of all move that across. X squared plus 3x minus 10 is less than 0, positive x squared, and it's going to be concave down. Let's find the roots of the function. X squared plus 3x minus 10, make that equal to 0. Two numbers that multiply give minus 10, add together give 3, is plus 5 and minus 2. So that's x plus 5 is equal to 0, or x minus 2 is equal to 0. X is minus 5, or x is 2. So there's a sketch, concave down. Now this time I'm interested in when the function is less than 0. Now it's less than 0 below the x-axis, which is down here, and that is between minus 5 and 2. Now let's just investigate. This is called a closed interval inequality, and it occurs when you've got a closed interval, so we can see that this is bound between minus 5 and 2. So this basically just means that x lies between minus 5 and 2. if you think about it, if I say that 3 is less than 5 is less than 7, that's a true statement because 3 is less than 5 and 5 is less than 7. Well, 3 is less than 5, then the converse of that statement, if it's 3 is less than 5, then 5 must be more than 3, but it's also less than 7. Well, minus 5 is less than x. It follows then that x must be more than minus 5, but it's still less than 2. So in essence, it means it's more than minus 5, less than 2, i.e. between minus 5 and 2. Okay, let's try another. X squared minus 5x is less than 0. So it's concave down. I'm going to take out a common factor of x. Bracket x minus 5 is less than 0. Okay, so let's find the roots of the function. So x is equal to 0, x minus 5 is equal to 0, x equals 0, x equals 5. It's concave down. I'm interested in where the function's less than 0, so again that's below the x-axis, that's in here, that is a closed interval, and that is x lies between 0 and 5. Okay, let's try another. This time, let's go for 2 plus x minus x squared is greater than 0. First of all, minus x squared is concave up. So minus x squared plus x plus 2 is greater than 0. That's a more familiar order. I'm going to find the roots by making the thing equal to 0. If it's equal to 0, I can then manipulate it so that it's easier to factorise, and multiply through by minus 1, that will give me x squared minus x minus 2 is equal to 0. Two numbers that multiply give minus 2, add together give minus 1, is x minus 2 bracket x plus 1. That's x minus 2 is equal to 0, x plus 1 is equal to 0. And that's x equals 2 and x equals minus 1. And it's concave up. So we're interested in when the function is greater than 0, so again that is a closed interval between minus 1 and 2. Minus 1 is less than x is less than 2. Okay, next one. 36 is greater than or equal to x squared. Okay, so bring that across, that will be 36 minus x squared is greater than or equal to 0. A minus x squared is concave up. I can then find the roots by making the thing equal to 0. That's a difference of 2 squares. 6 plus x bracket 6 minus x is equal to 0. 6 plus x is equal to 0 and 6 minus x is equal to 0. And x will be minus 6, or x is 6. And it's concave up. We're looking for where the thing is greater than or equal to 0. So it's greater than 0 above the x-axis and equal to 0 at the x-axis. So that is between minus 6 and 6, but crucially including minus 6 and 6. So it's minus 6 is less than or equal to x is less than or equal to 6. Okay, let's try another. 8 plus 2x minus x squared is less than or equal to 0, so that's concave up since it's a negative x squared. Let's put this in a more familiar form. Minus x squared plus 2x plus 8 is less than or equal to 0. We then identify the roots by making the thing equal to 0. I can now make it easier to factorise by multiplying through by minus 1, so let's change all signs, and I can do that because the thing's equal to 0. 0 times minus 1 is still 0. Two numbers that multiply give minus 8, add together to give minus 2. That'll be x minus 4 bracket x plus 2 is equal to 0. X minus 4 is equal to 0, or x plus 2 is equal to 0. And that will give me x equals 4 or x equals minus 2. concave up. I'm looking for when the function is less than or equal to 0, so that's below the x-axis and at the x-axis. So we can see that that is when x is less than or equal to -2 and when x is greater than or equal to 4. Okay, next one. 2x squared plus 11x plus 5 is less than or equal to 0. Positive x squared, concave down. Okay, so two numbers that multiply give 10, add together to give 11. That will be 1 and 10. So whichever way that you factorise this one, just go ahead and do it. So I can't factorise the first bracket, write it down again, but I can take out a common factor of 2 here. So divide by 2, and that will bring me down to x plus 5. I've then got 2x plus 1 is equal to 0, and x plus 5 is equal to 0. 2x equals -1, and x equals -1/2, and x equals -5. So a root at -5 and a root at -1/2, concave down. I'm interested when the thing is less than or equal to 0, so that's a closed interval. So that is between -5 and -1/2, but including -5 then is less than or equal to x is less than or equal to -1/2. Okay, let's try another one. 8 plus 18x is greater than 5x squared. So bring that across and that will be 8 plus 18x minus 5x squared is greater than 0. Negative x squared term, so it's going to be concave up. Let's put this in a more familiar form. Minus 5x squared plus 18x plus 8 is greater than 0. Let's find the roots by making the equation equal to 0. Since it's equal to 0, I can then make this easier for factorising. Change all signs to get a positive x squared by multiplying through by -1. 0 times -1 is still 0. 5 times -8 is -40. Two numbers that multiply give -40 and add together to give -18. So it's going to be -20 and +2. Okay, I'll drop 5x in here and 5x in here. The second bracket can't be factorised further, but I can take out a common factor of 5 here, which would bring that down to x minus 4. So x minus 4 is equal to 0 and 5x plus 2 is equal to 0. X would be equal to 4 and 5x is equal to -2, which means x is -2/5. Okay, so it's concave up and a root at 4 and a root at -2/5. And I was interested in when the function was greater than 0. So that's up here. So that is between -2 and 4.